Okay, so just a couple short answer questions. So go ahead and fill in 1A, B, C, and D. Again, we're just going to do this together, so stay together. Go ahead and do 1A, B, C, and D. Pencil, pen, I really don't care. Although when we get to the problems, you want to use pencil. Everybody's got the calculator out, right, to do the factorial. Would you be happy with this many pennies?
Yes. Yes.
Because you'd have almost $400,000. So, because it's what, 39,916,800, right? 39 million. By the way, if anybody has any makeup work, if you'll pass it up and I'll get that from you. So, situation is, why do I want you to know trial and error? Because I want your brain to say, when you look at a trinomial, trial and error. So that's why that's an important question. Because if your brain says trial and error, you might actually begin to solve it correctly. Same thing with 1b. I want you to look at a binomial and say, okay, is that a difference of two squares? And if you say, oh, it is a difference of two squares, then your brain should say, okay, this is how we do these. 1c, you have got to know 1c. You've got to know 1c. You got to know 1c. Because it's what you got to think on every single factoring problem, right? Factor out common factors first, and then the value of 11 factorial. If I asked you to expand it, you would say 11 times 10 times 9 times 8 times 7 all the way down. If I ask you for the value, then you're punching in the value, okay? Any questions on 1A through D? 1A through D. Connor. And how is that a question on 1A through D?
Because I couldn't do 11. So, yeah. Or 1D.
You can ask me for a calculator when it's time for you to ask me for a calculator, but it's not time yet. I'm not going to reward you for gaming the system. All right? So you got to know the names, you got to know what's going on, you got to know the situations there. That is important. All right, so before we get to the factoring section, it is really important that you remember how we started factoring. The way we started factoring was the only thing we did was factor out common factors. Here's what's going to happen tomorrow to some of you. There's going to be a problem. The only thing to do is to factor out common factors. That's it. And you're going to try to do a whole bunch of other stuff. And you're going to get goofed off right from the beginning, and it's going to mess up the whole test. You don't want to be that person. You don't want to be that person. So realize, factoring, sometimes it's just taking out common factors, period. That's it. That's all. So when you get to a problem, that's the first thing you got to look for anyhow, factoring out common factors. Then you have to look at what's left after you do that. Is what's left a trinomial? Okay, think then, can I factor this trinomial by trial and error? You'll have to look at it to see if it looks like the trinomials we've been factoring. If it doesn't look like anything we've done, then that's it. You're done. You just factored out common factors. Which, by the way, that one's not prime, is it? Because you did get something out, you did factor. If when you factor out the common factors, what's left is a binomial, Now you have to stop and say, oh, is this binomial a difference of two squares? If it is, then you gotta go about factoring that difference two squares. If not, then that's it. That's all you had to do was factor out common factors. Be careful. Be careful. Be careful. Be careful. Be careful. Be careful. All right, why don't you do the first three of them, 2, 3, and 4. Any other questions about anything else? Okay. Okay, I realize I may not have given you enough time for all three of those, but at this point, just stop where you're at. Don't keep working so that you can take the benefit of the review. All right. So again, I realize the time, it will be an issue tomorrow, and I will try to give you the absolute most time possible to take your test. When you come into class tomorrow, you want to come in ready to take your test. So when you come into the room, you should already have your cover sheet ready to go. It's fine if you want to look at your notes those last few minutes, but just be ready to close them up and have your calculator, cover sheet, something to write with already ready to go so that you can have as much time as possible to take the test. Okay, so again, you look at the first problem and you say to yourself, I have to factor out common factors first. So you look and you say, oh, there's a common 3 and there is also a common n. When I take out the common 3 from the 18, and 18 is a 3 times 6, so the 6 is left, and n squared is an n times n, so the n is left. When I take out the common 3 from the back, 15 is 3 times 5, so the 5 is left, and the n is gone. So now I look at the binomial and I say, is this a difference two squares? And the answer is no, so I'm done. That was all. Factor out common factors. Now again, if you start trying to factor that binomial, you're just wasting time and getting the problem wrong. And you don't want to do either one. Any questions on, how many got number 2 correct? Okay, that's very bad. I see only about half of your hands. Talk to me. What are some of the things going on in your brain that cause you to get it wrong? Anybody want to give me some feedback here? Help me understand where your brain's at? Byron?
Right. It's supposed to be a minus sign over plus sign.
Okay. But that's close. So that's an easily fixable thing because that minus was there in the beginning. We almost never factor out a negative, though you can. If you factor out a negative, every sign changes, and if not, the signs all stay the same. Anybody else have any feedback that might help someone else as well? No one willing to say? All right. Again, do you understand how that's not a difference two squares, and therefore, does everybody understand that or not? Anybody not understand that? Want me to explain that more fully? Why it's not a difference two squares? Okay. So because the n isn't squared right off the bat, that can't be a difference two squares. That variable either has to be squared or 4th power or 6th power or 8th power. It's got to be some even power. Otherwise, right off the bat, not good. So that was one thing. The other thing is 6 isn't a perfect square, right? 4, 9, 16, 25, 36, anything you can evenly take the square root of has to be that number as well as that one. So that one failed in 3 areas, but as soon as you see it's not squared or to the 4th, boom, it's not a difference two squares, move on. Okay? All right, the second one, you go to look for factoring out common factors and you see none, and you say to yourself, oh, this is a trinomial, trial and error, right? And so you say, I need 2 parentheses. You say the fronts have to multiply to the front, so that's x and x, easy one. The backs, you say, have to multiply to a negative 12, but remember, it's all about the middle. You are going to choose factors of negative 12 that will allow you to have a negative 4x in the middle. Again, my brain, I'm thinking if I go negative 6 here, that's a negative 6x. That leaves my positive 2 for here, for a positive 2x on the inners, which indeed gives me that negative 4x, and that one's done. Again, your thoughts have to be, when I use these factors of negative 12, what do my outers produce? What does my inners produce? When I add them, do I get the middle? It's all about the middle. Just make sure you're using factors of negative 12. Can you use positive 3 and positive 4? No. Can you use positive 2 and positive 12? No. Can you use negative 2 and negative 6? No. You got to use factors that multiply to negative 12. All right, so then if you had time and you got to number 4, hopefully you saw the common 4. And so that leaves the z squared, a negative 10z, and a negative 6. And you got to have that step. You got to have that step. You got to have that step. Now, you might be done. But this is a trinomial, and it's classic. Look, the variable is squared. You got one of the same variable in the middle, and you got a number on the end. That's classic trinomial that factors. So we got to try it. All right, don't forget the 4. Some of you guys forget that 4 that's out front. Don't forget it. The trinomial, again, 2 parentheses. The fronts have to multiply to the front. The backs have to multiply to a negative 6. And I've got to try to get a negative 10 in the middle. Now look, I gave you an easy one. The only front possibility is z and z. 6. 1 and 6, 2 and 3. That's it. What's the biggest number? 6. There's 6 of them, 1 of them. Is that going to get me to 10? There's 3 of them, 2 of them. Is that going to get me to 10? Now, I hope you didn't write prime in the blank, because it's not prime. The trinomial doesn't factor, but the problem did factor into 4 times the quantity, z squared minus 10z minus 6. Because we did factor out a common 4. We did factor the thing. Now, if you keep spending time on this, why are you spending any more time? 1 and 6, 2 and 3, that's it. Now, are you writing it out every time? Maybe you are, and therefore you keep spending all your time writing. And some of you guys are slow writers. Again, you got to get it to where in your mind you're thinking 6 here, 1 there, that's not going to get me to 10. 3 here, 2 there, that's not getting me to 10. So again, watch the screen. Watch right here. Again, you're always thinking outer times outer. Hey, 6 and inner times inner. 6 and 1, that's a 7. A 2 and a 3, that's a 5. None of them gets me to 10. This thing doesn't factor. The trinomial doesn't. But the original trinomial does factor as far as taking out common factors. How many got number 4 correct? Okay. And if you didn't, you see now what we're doing there? Any questions on those first 3? Any questions? Okay. Let's just go ahead and do number 5. Go ahead and do 5. Okay, again, I know some of you may not be done yet. Hopefully you did look to factor out common factors. Are there any? No. So trial and error, 2 parentheses. The front has only one choice, 3n and n. That's it. But guys, this 3 makes a big difference in where you put the numbers from the negative 8. That 3 makes a big difference. And always know where you're heading. And where am I heading? To a negative 2n, right? In the middle. That's where I'm heading. That's where I'm going, to a negative 2n. So I got negative 8, and I got to end up with a negative 2. Now watch. I wouldn't write this. This is what I would think. So watch. You're better off watching at this point and gaining from my trying to help you again. I don't write this. I think this. With a negative 24 there, am I ever going to get to negative 2? No way. I know that 8 doesn't go there. There's just no way. I know it doesn't go there. And so I know that it's not that. Windows is really being a pain today. Come on, get up there. More, so much more. All right. So I know that's not an 8 there. I know it's not. I don't even write it. I'm just trying to show you guys what I'm thinking and how I'm doing these things when I think. So again, I have 1 and 8, 2 and 4. Now, if I put the 1 in the back, that gives me how many? 3. And that gives me an 8 in the middle. Will a 3 and an 8 ever end up being a -2? No. So it's not that. So it's not the 1 and 8. 2 and 4 is left. Again, in my brain, I wouldn't do this because I know the big number's not going in the back. But if I put the 4 in the back, I already have 12. That leaves 3 in the middle. Is that going to get me to -2? No. I really have one shot on this thing. 3, and I need most of them to be negative, and I need the least of them to be positive. What's my outer? A -9n, and what's my inner? A +4n. That's not it either. So does this thing that's area, hold on, that's 12. No wonder. I'm thinking, what in the world? All right, that's a 2. No, that's a, what in the world is going on? That's a 2. Good night. Mamma mia. All right, so how about -6, +4, ding, 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 ding. Gave me the middle, right? Don't get goofed up on your numbers like that. So there's a factorization. 3n plus 4n minus 2. How many got that one right? See, there weren't a ton of possibilities on that one either. There really weren't. And if you know what you're doing, if you're thinking outers plus inners toward a -2, you should be quickly eliminating your choices. Okay. All right. Try number 6. All right, so I'm going to speed up a little bit here. Okay. Can you factor out any common factors on 6? No. 6n and n, or did you catch the fact that there are 2 possible front pairs? How many caught the fact that there are 2 possible front pairs? Yeah, you have to, because if you choose the wrong front pair off the bat, you're never going to find the factorization. So now I got to deal with a +10. And by the way, whenever the middle's negative and the back is positive, it's always negative times a negative. Has to be. Can I do 1 negative, 1 positive? No, it's got to be negative times a negative. So 10. I can go 2, that's 12, and 5, but that's only going to get me to 17. That's not working. And again, I'm thinking this in my head. I'm not really writing it. I could go 10 and 6, and that's 16. I can go 12 and 5, but that's 17. I can go 5 and 2, but that's 30 and 2. None of those work, right? So again, if you're not aware that could also be 3n and 2n, you're going to miss all those possibilities. And it may have been that one. So again, 5 and 2, 15 and 4. Oh, that's 19. 3n minus 2 times quantity 2n minus 5. The -2 has to be with the 3n, and the 5 has to be with the 2n. How many got that one? Okay. So again, on that one, you had to be aware of, oh, there are 2 possibilities. All right, for time's sake, I'm not going to deal with the next one. I'll just do it real fast for you. Are there any common factors? Yes. Common 3. Minus 9b squared. Just watch. While you're writing, just watch. You didn't take time writing, I'm already teaching. Just watch. So I got a common 3 out. Now I'm going to try the trinomial. 2a and a, those are the only possibilities. By the way, don't forget your b in the back, right? So what do I have? 9 and 1, 3 and 3. Oh, 3 and 3. That gives me 6. And that gives me 3. And I need the 6 to be negative. 3 times the quantity 2a plus 3b times the quantity a minus 3b. That's the way my mind works. It'll do you no good to write that answer. Again, you're just wasting time. And I want to get to your homework as well. So what happened to the second page? It should have been up there already. Let's look on the back. So you look at number 8 and you say, factor out common factors first or none, and then you say, oh, it's a, go ahead and factor it. Difference 2 squares. If you're not done yet, you're not sure what you're doing yet, you haven't memorized the procedure and you need to. 2 parentheses. 2 parentheses. Plus in the middle of one, minus in the middle of the other. The square root of the first in the front, the square root of the back in the back. That's it. Quantity x plus 6 times quantity x minus 6. How many had that one correct? Okay. Those you should find easy. All right, go ahead and do number 9. Go ahead and do number 9. All right, I know I only gave you a minute. Did you factor out the common 7? How many took out the common 7? Okay, there you go. I keep telling. How many times have I told you factor out common factors first? How many times? Like a million. Yes, got to be your first thought every time you factor. Factor out common factors first. Take out the common 7. 28 is a 4 times 7. Now what's left is a difference of 2 squares. Plus in the middle of one, minus in the middle of the other, square root of the front in the front, square root of the back in the back. How many got that? Okay, and again, a lot of you didn't factor out common factors first, so you got to factor out common factors first. All right, number 10 is like what we did for homework last night. Are there any common factors on 10? It's a binomial, so is it a difference of 2 squares? It's got a minus between. Is the front a perfect square? Yes. Is the back a perfect square? Yeah. It's a difference of 2 squares. 2 parentheses. Plus in the middle of one, minus in the middle of the other. Right? Square root of the front goes in the front. The square root of n to the 4th is n squared. Square root of the back goes in the back. Square root of 16 is 4. Are we done? The front one is done. There's nothing you can do with that. It's not a difference 2 squares, but the back one is a difference 2 squares. 2 parentheses. Plus in the middle of one, minus in the middle of the other. Square root of the front in the front, square root of the back in the back. And that would be the answer. All right, the bonus, if we were doing it, come on. Ugh. If we were doing this as a quiz, first off, common factors. Are there any? Is there the same factor in all 4? No. Is it a trinomial? No. But I will try trial and error. The fronts always multiply to the front. There's really only one choice, 3x squared and x, or you could be x squared and 3x. That is possible. Could be x squared and 3x. I got to be careful. Back has to be a positive 6. And what am I after in the middle? A negative 9x squared and a negative 2x. I know I'm going to use negative and a negative. Hey, if I go negative 3 right here, isn't that a negative 9x squared? Now, this has to be negative 2, but oh, look at that. There's the negative 2x. So that is the factoring of that. Now I do want to look right here. Is this a difference of two squares? Is a 3 a perfect square? No. And is a 2 a perfect square? No. So no, that's it. We're done. By the way, we could creatively factor that, but we're not doing those yet. And that would be the answer. Okay. Every once in a while, the yellow box will be a difference of two squares, and you can continue on. All right, take your homework out, and I got to go over that. Go ahead and grade your own. Don't swap them. Grade your own. All right, number 1 should have ended up 5 times the quantity a plus 1 quantity squared. Remember, whenever you have the same factor more than once, write it in exponent form. So you should have factored out common 5, and then what's left should have factored in a plus 1 times a plus 1, therefore a plus 1 quantity squared. Any questions on number 1? Anybody need me to show you anything on number 1? Okay, number 2. 2 ends up being x times the quantity x minus 1 quantity squared. You should have factored out a common x. Then what was left should have factored in x minus 1 times x minus 1 for an x minus 1 quantity squared. Does anybody want me to do number 2? Anybody? Okay, number 4. Number 4, you got a 2a to the 6th you should have gotten out. And that would have left a difference of two squares that becomes 2a plus 1 times 2a minus 1. So 2a to the 6th gets factored out times the quantity 2a plus 1 times the quantity 2a minus 1. Would anybody like me to do that one? Raquel? All right, so Raquel, when you factor out the 2a to the 6th, you should have had 4a squared minus 1. Did you have that when you factored it out? Okay, this is a difference of two squares. So, 2 parentheses, plus in the middle of one, minus in the middle of the other, square root of 4a squared. Square root of 4 is 2, square root of a squared is a. So 2a goes in the front, square root of 1 is 1, 1 goes in the back. Okay, and that's how that one ends up. Number 6. You should have gotten a 3a cubed out, and then 3a squared minus 4. That one doesn't factor anymore. All you did was factor out the common a cubed. That's it. How many got number 6 correct? What did you all do to it? Did you try to treat it like a difference of two squares? So what'd you do with the 3? Well, it's got to be the square root of the front, right? So again, your recognition skills need to be a little better in saying, now everything else was good on that one. It was squared, there was a negative, there was a 4, but the 3 goofed you up. That means that one was done. That one was done because you can't take the square root of 3 evenly. All right, number 7. Take a common 5 out. Then you end up with x minus 7 times x minus 7. So it's 5 times the quantity x minus 7 quantity squared. Number 8. You do trial and error. You end up with m to the 5th plus 1 times n to the 5th plus 1. So it's m to the 5th plus 1 quantity squared. Remember, whenever you have the same factor, you will write that factor to the proper exponent. Any questions on 8? Any questions on 8? Caitlin?
How'd you get that?
All right, so 8 was m to the 10th plus 2 m to the 5th plus 1. Do you agree there are no common factors? What did you put in the front of yours? On both? Okay. So now you only have a 1 and a 1. So watch, if I put a plus 1 there, excuse me, this is an m to the 5th. When I put a plus 1, that's an m to the 5th, and one of them is 2 of them. 1 m to the 5th and one more m to the 5th is 2 m to the 5ths. One of them and one of them is 2 of them. All right, I know you didn't see it, but that is what it is. All right, number 7. We did. Number 8, we just did. Number 9. Number 9, factor out the common 2x minus y. And so you get that's got to be in parentheses. Parentheses 2x minus y times the quantity x plus y. Let's do 10 because it's just like it. Quantity 4 minus, I'm sorry, do it this way. The quantity b plus c times the quantity 4 minus m. The quantity b plus c times quantity 4 minus m. How many got number 10 correct? Okay. And remember, a quantity is just like a common number, like a common 2, like a common 7, like a common x. You take out the whole parentheses, Byron.
Switch the order. Like,
Why would you? Why did your brain have a different order? Whose brain would say it differently? Now, the book gave it differently, and that's why I didn't give it that way. Because everybody factored out the common b plus c, right? Isn't that what, how many did that? Took out the common, so why would your brain have the other order? Because you always take what comes out in front, right? So I don't know why the book did it the other way. That's certainly not the way the brain would be working. It certainly wouldn't display. So you could, yeah, it's true, Byron, but I just don't know why the brain would think that way. All right, 17. 17 is long, but it wasn't odd, so I'm going to skip it. 18. 18 ended up, look at 18. Again, I don't know that I agree with the books. Oh, here, this is the order I would have it in. A squared x squared plus 9 times ax plus 3 times ax minus 3. It started out as a difference of 2 squares, and then the second one was still a difference of 2 squares. So the first one was a difference of 2 squares, plus in the middle of one, minus in the middle of the other, square root of the front in the front, square root of the back of the back. And then your back one is now another difference of 2 squares. Plus in the middle of one, minus in the middle of the other, square root of the front in the front, square root of the back in the back. How many got 18 correct? Okay, good. That's good. That is good. 25. I got to get to those last few weird ones. 25 is just, well, that's an odd, you guys saw it. 26 was like 25. It's an x minus 3y and an x minus 2. It was a 4 one that you could just do like a trinomial, trial and error. Because the front's x times x gives you the front x squared, and a negative 3y times a 2 gives you, times a negative 2 gives you a positive 6y in the back. You could have just treated it like trial and error. Or you could have factored out a common part of fronts and backs, but I think it's easier just doing trial and error. How many got 26? Okay, right? Just treat it like 2 parentheses and try it. It really did work, and it wasn't that bad. All right, 30. 30 was a little bit odd. 30 was the kind where you had to do that trinomial in the front. So 30 actually ended up with a plus 2 times the quantity a plus 3, a minus 3. A plus 2 times the quantity a plus 3, a minus 3. And again, that could be in any order. You could have treated it like a trinomial and 2 parentheses, and then you would have had a difference of 2 squares that you could keep going on, right? So this part, you would end up with maybe an a squared minus 9 times an a plus 2, and then you factored the a squared minus 9, difference of two squares. Make sense? Okay. Good. 43, 44. Did not give you any of that other kind? Ooh, bummer. All right, 43 and 44, for time's sake, I'm not going to go over. Before you pack up, you got chapter review with odd problems. It would be my advice to work some of those. Work the kind that give you trouble. I didn't see any of this kind, so be careful. Right? That's a difference of two squares, isn't it? The front is a perfect square. There's a minus in the middle. The back is a perfect square. Two parentheses, plus in the middle of one, minus in the middle of the other. Square root of the front in the front, right? Square root of the back in the back. Oh, numbers and numbers I can combine. Numbers and numbers I can combine. Okay, that's odd. That's a really weird one. I can factor out a common 2 out of both of these. This is a really weird one. All right, that's a very, very odd one. I don't want to go any further because it'll mess up your brain. All right, that's it.